In exercise 3, we will talk about XGBoost. In 3a, we will explain XGBoost and what the difference is to conventional gradient boosting. So XGBoost stands for Extreme Gradient Boosting. And it actually is a form of gradient boosting, or let's say it uses gradient boosting. And it is a algorithm, or it's a form or a method that can be applied that is very computationally efficient. Um, so it parallelizes the process very nicely, and therefore computation is done in a very short amount of time. Also, it uses regularization to reduce overfitting. And we can see that if we have a look at the loss function, so this part is actually just like in gradient boosting, but then we add this penalty term, which you know from, so this procedure of including the penalty term in the loss function, you know from ridge regression, for example. And so what does this penalty term look like? So this part here penalizes the tree size. And this is necessary because actually we will grow out our trees, which is also different from the previous models. Like often in normal gradient boosting models, you will just use very short trees, so very weak learners, and combine these. But here we will actually grow out the trees and then penalize this the the depth of the tree. And the second term here penalizes the size of the forecasts. So basically, unnecessary forecasts will be set to 0. Okay, so similar to the coefficients of in ridge regression, which also scales the coefficients that are less influential to 0. So this part was like in gradient boosting, and this is then the regularization term. And that's besides the computational advantages and different other advantages that are not maybe that important to discuss right now. So then regularization and this computational advantage are the most important or most prominent advantages of XGBoost. And also it's very easy to apply actually, and the default settings yield quite good results.